You know, for the longest time, the recipe for smarter AI seemed super simple. Just make it bigger. More data, bigger models, more computing power. But we're kind of starting to hit a wall, a point of diminishing returns. So the really big question that researchers are wrestling with now is this: how do we get AI to be smarter without just making it more massive?
All right, so here's the game plan. First, we're going to talk about why that bigger is better approach is running into problems. Then we'll dive into 3 really fascinating new ideas: getting models to basically think harder during a test, teaching them to reason in a language that isn't even human language, and training them to discover how to think for themselves. And finally, we'll tie it all together.
So yeah, let's set the stage. For years, the main playbook for improving AI was just scaling everything up. Bigger models, massive datasets. And look, it worked. It's exactly how we got the incredible models we have today.
But you gotta ask, right? As these models get just astronomically huge and wildly expensive to train, can this really be the only path forward? What if we've been putting all our chips on the training part of the equation and we've been totally ignoring a massive opportunity on the other side?
And that brings us to our first huge idea, and this is where things get really interesting. What if, instead of just training a model into the ground, we could let it think a little harder when it's actually trying to solve a problem? This whole concept is called scaling inference-time compute.
I love this analogy because it just clicks. Think about it. Training time compute? That's cramming for an exam. You just shove as much information into your brain as you possibly can. But inference time compute, that's like the teacher giving you extra time during the test. You can actually sit back, think about the question, maybe try a couple of different approaches, and even check your work before you hand it in. And this leads us to a just brilliantly simple paper with a great title: Large Language Monkeys. It's a nod to that old thought experiment, you know, the infinite monkey theorem, where if a monkey just randomly mashes keys on a typewriter forever, it'll eventually type out all of Shakespeare. So the researchers thought, what if we applied that same kind of brute force thinking to an AI?
So here's how it works, and it's almost ridiculously simple. Let's say you have a coding problem. You just tell the AI, hey, generate hundreds of different ways to solve this. Then you use something that can automatically check the answers. In this case, you can just use the project's own built-in unit tests. And you just check each one by one, until you find the first one that passes all the tests. That's your answer. Simple, right? But wait till you see how well it works.
And get this, the results are just wow. A model that only got about 16% of these real-world coding problems right on its first shot suddenly solves 56% of them when you give it 250 tries. And that doesn't just beat its own personal best. It completely blows past the previous record of 43%, which was held by giants like GPT-4o. It's a massive, massive jump just from letting the model try over and over again.
Okay, so brute force works, but can we be smarter about it? Well, new research from folks like Snell explores a much more elegant approach. Instead of just blindly generating tons of answers, what if the model could intelligently decide how much effort to spend? You know, for an easy problem, maybe one shot is all you need. But for a really tough one, maybe the model should revise its answer or search through a whole tree of possibilities.
And this quote is the money shot. It's absolutely staggering. By using that thinking time efficiently, a smaller model can actually perform better than a model that is 14 times its size. That completely flips the script on how we think about building and using AI. Thinking harder really can be way, way better than just being bigger.
All right, let's switch gears a little, because this next idea is a real mind-bender. So far, we've been talking about how an AI thinks, but what about the actual language of thought itself? For the AIs we have now, that language is, well, it's English, or Japanese, or whatever human language it was trained on. But what if that's actually holding it back?
So right now, the gold standard is something called chain of thought. It's where the model literally talks itself through a problem, right? It generates a sentence, then another, laying out its reasoning step by step. It works, for sure, but it also forces the AI to think in this very linear, one word at a time kind of way. But what if, and this is wild, what if the AI could reason in its own, private, abstract language? That's the idea behind a new paradigm called coconut, or continuous thought. Instead of thinking out loud in English, the model works in this compressed space of ideas. It generates a thought vector, a bundle of abstract concepts, and feeds that back into itself to continue reasoning. It's like having an internal monologue, but in a language made of pure concepts, not words.
And the difference here is profound. Think of it like this. Reasoning in words is like walking down a path in a forest. At every fork, you have to choose left or right. You have to commit. But reasoning in vectors, it's like it can kind of explore both paths at once. Because it's a continuous state, it can hold multiple possibilities in suspension, which is way more efficient for problems that require planning or searching for a solution.
Okay, so we've seen how AIs can think harder and even think in new languages, but this third idea is maybe the most ambitious of all. What if we could teach an AI to fundamentally get better at the process of reasoning, all by itself?
And that's the core idea behind a new model called DeepSeek-R1. Instead of showing it a bunch of examples of good reasoning and saying, copy this, they used reinforcement learning. It's kind of like training a dog, you know? You just set up a system where the model gets a reward when it gets the right answer, and then you just let it figure out the best way to get that reward. They didn't even need to give it examples to get started.
Now this is where it gets crazy. Look at what happened during training. This graph shows how long the model thought about problems over time. And as it trained, it just spontaneously started generating longer and longer and longer chains of thought. Nobody programmed it to do this. It learned on its own that to solve the hard stuff, it needed to spend more time thinking.
And what was the result of all that extra thinking? Well, take a look. As the model's reasoning got longer, its accuracy on a super difficult math test just soared. It went up and up, eventually matching the performance of some of the best closed-source models out there. The cause and effect are just crystal clear.
But maybe the most incredible part is that it didn't just learn to think longer, it learned to think better. All these sophisticated behaviors, like checking its own work, backing up and reevaluating its ideas, exploring different solutions, they all just emerged from that simple reward signal. Nobody told it to do these things. It discovered them because they were good strategies for solving problems.
Okay, so let's pull all these threads together. We've just covered three really distinct, really powerful new ways to push AI reasoning forward that have nothing to do with just making the models bigger. So how does this all fit?
This slide really lays it all out for us. You've got the classic approach, just make the model bigger at training time. But now we have these three new frontiers. We can make the model think harder at test time. We can make it think in a totally new, more efficient language. And we can use RL to teach it how to think in the first place. Each one is a brand new tool in the toolbox.
And here's the big takeaway. This isn't an either-or situation. These ideas aren't competing with each other. They're complementary. You can easily imagine the next generation of AI systems combining all of them. A model that's taught how to reason using RL, that does its thinking in an efficient latent space, and is given all the extra compute time it needs to really chew on a difficult problem.
So at the end of the day, it leaves you wondering, right? As we teach these machines to think harder, to think in new ways, and to learn how to reason for themselves, are we just building better, faster calculators? Or are we maybe, just maybe, taking the first steps toward creating a completely new kind of mind? That's definitely something to think about.